Alright, this is 5.2, exponential functions and their graphs. This is part 3, and we're going to talk about example 3 here. This is a case where we have a base of 2, and then we have an exponent of the quantity of x minus 2. And this minus 2 is going to make our x move one way or the other. And I'm going to point out that it's going to behave very much the same way that it did when we were talking about our quadratic function in the vertex form. Remember, we had this a, and then we had the quantity of x minus h, that whole quantity squared plus k. And this h, we ignored the negative here. The h itself told us whether we moved left or right. Well, in this case, this is almost the same thing in the way it behaves. Now, it is not the same thing as a quadratic equation. They're two very different types of functions, but I want to be sure that we're clear on the fact that this x minus 2 means that I'm actually going to move my values over 2. All right? So if we were to take our 2 minus 2, that's going to give us our 0. And when we look at our values, that is in fact true. All right? So it's going to be shifted to the right when we have by 2 units. If we had something where it was that double negative, so if I had, just as an example, I have y equals 3x minus a negative 5, right? A lot of times we might see it like that, but most times we're going to see that written as 3 times x plus 5. And that's where we need to keep in mind. This is actually saying we're moving to the right, or we're moving from the right to the left, these 5 spaces. So you got to be super aware of what this is telling you on your x and on your x values, whether it's moving to the left or to the right. All right. So I'm going to go on from there. Let's see here. Here we have, and again, this is really similar. We were just talking about it. The format is similar to the fact of our a to the x minus h quantity squared plus k. And in this case, this is going to behave similarly to the plus k here. All right, so when I have this minus 4, that's saying I'm going to go down or up. If it were a positive 4, it would go up 4. In this case, it's going to go down 4 units. Okay? And that should be, that should be pretty evident as to what's happening there. So in this case, our x is not affected, right? This is just whatever the x is, and then this is saying we shift this all down. All right. All right. In this case, this is a little different, and the way it's written, I think, throws people sometimes. Mostly we've been seeing that whole, some number raised to the x power, right? Here, we're actually going to write it a little differently. I'm going to rewrite this to be minus 0.5 x plus 5. All right? So this negative flips it so that instead of coming down like this, right? Instead of coming down like this, it's going to flip it over. So that negative flips it over. And then this, it tells us that it's approaching, or it's going to approximately aim towards that 5. That's as high as it's going to go. Now, if this was not negative, it would just have shifted this up, right? So that's something to keep in mind. I think that seems pretty straightforward. If not, then feel free to ask questions, right? It's going to be the reflection. Remember the 0.5 is going to be a 1/2. So, and then it's shifted up by 5 units. All right, here's a couple examples of actual exponential functions. This is information that was taken on November 10th. This is the total coronavirus cases in Minnesota. And you can see, and this is real life, this hasn't been smoothed out and made perfect, but you can see that this model is approximating a quadratic or an exponential function. It starts off really flat, and then it starts to increase, and yeah, there's a little wiggle here, but again, we're looking at the big picture. This is increasing, and it's starting to really take off here. It's really starting to accelerate up. So this is an example of an exponential function that has a real life, probably more than we want, real life circumstance. Here is another. This is the example of hospital capacity and how much of it is being used for COVID. All these are both saying COVID. This is non-ICU. This is ICU. You can see that this thing is accelerating up. The difference between these two is once someone has been diagnosed with COVID, it usually takes about 2 to 3 weeks before they need to become hospitalized. That isn't always true, but it often is true. All right. So here's another application, probably a little friendlier. If you have a case of interest where you're either getting interest on a savings account or an investment, or if you are taking out a loan or using your credit card, this is how you would use this. Okay, this is where this comes in. Actually, you know, I'm gonna pause this here and we'll come back to it, but I want to just set up the fact that this is going to be our compound interest. All right, we'll come back to this in part 4.